Need to lock down your FastMCP tools so only authorized users can execute them. You'll see how to add policy-based authorization in just 2 lines of code using Eunomia's middleware. We'll create a secure server that automatically filters tool listings and blocks unauthorized calls, all controlled by a simple JSON policy file.
From FastMCP, import FastMCP. From Eunomia, MCP import create Eunomia Middleware. Hash create your FastMCP server. MCP equals FastMCP, secure MCP server. At MCP, tool. Def add a int b, int. Add 2 numbers. Return a +b. Hash add middleware to your server. Middleware equals create Eunomia middleware. Policy file equals MCP policies, JSON. MCP, add middleware. If name equals main. MCP, run.
This demonstrates the middleware pattern combined with declarative tool registration for building secure RPC servers. The code shows how to layer authorization logic transparently over existing functionality, where the Eunomia middleware intercepts requests before they reach your tools, while the @MCP tool decorator maintains clean separation between business logic and infrastructure concerns. The system works through 2 key mechanisms: declarative tool exposure and policy-based interception. Tools are registered via decorators, keeping your implementation pure Python, while the middleware layer applies authorization rules defined in a separate policy file. This creates a clean separation where access control becomes a configurable infrastructure concern rather than being hard-coded into your business logic. This approach solves the common problem of retrofitting security into existing systems without rewriting core functionality. You gain fine-grained access control over tools, resources, and prompts with minimal code changes, while maintaining a single source of truth for policies. The pattern is particularly valuable for AI integration scenarios where you need to expose capabilities selectively to different agents or users. Let's break it down.
From FastMCP, import FastMCP. From Eunomia, MCP import create Eunomia middleware.
Imports FastMCP, the core server class for exposing Python functions as AI callable tools, and create Eunomia middleware, which adds policy-based access control to the server. These are the foundational components for building a secure, AI-integrated tool server.
Hash create your FastMCP server. MCP equals FastMCP, secure MCP server.
This instantiates the FastMCP server, the core controller for AI callable tools. The string parameter sets the server's display name used in logs and client interfaces. This is the entry point for all tool registration and request handling.
At MCP, tool. Def add a int b, int. Add 2 numbers. Return a +b.
This @MCP tool decorator exposes the add function as an AI callable tool. FastMCP automatically converts the type hints and docstring into a structured schema that AI models use to understand and invoke the function. The pattern ensures consistent, type-safe tool definitions across your server.
Hash add middleware to your server. Middleware equals create Eunomia middleware. Policy file equals MCP policies, JSON. MCP, add middleware.
This injects Eunomia middleware for policy enforcement. The middleware loads rules from MCP policies, JSON, to validate, authorize, or transform every incoming request before execution, critical for security and access control in production deployments.
If name equals main. MCP, run.
This is Python's standard entry point guard. It ensures MCP, run, only executes when the script runs directly, not when imported as a module. Without it, importing this file would unintentionally start the FastMCP server. Authorization through absence. The Eunomia middleware transforms FastMCP servers by making unauthorized tools invisible rather than blocked, creating security through controlled absence. Policy files must be valid JSON and properly referenced, or the server will fail silently during authorization checks. A single line of middleware code replaces what would otherwise require custom permission logic in every tool.
The gateway that shows nothing guards everything.